We have been talking about finding the derivative of a function. Let's go over what it is one more time. So we have a function f of x. So f of x is some curve. When you find f prime of x, we are finding one function to describe the slope of f of x at any x value. So you either use the shortcut or you use the limit definition to find f prime of x. So now you do the algebra and then you got your f prime of x. So when x is equals to a value, so let's say x is equals to 5. So what that means is you have f of x, you want to know the slope of f of x when x is equals to 5. Since you are looking for the slope, you plug in x equals to 5 to f prime of x, and then you do the plug in x equals to 5, you do the math. So let's say the slope is equals to 10. So that means for the curve f of x, when x is equals to 5, the slope is equals to 10. Now, the next question is the function f of x always differentiable at any x value? So let's take a look at the graph I gave you. So let's just take a look at the very first one. I wrote discontinuity. The function I gave you is f of x equals to 1 over x squared at x equals to 0. So do you see that when x is equals to 0, there is actually a vertical asymptote. So is the function differentiable at x equals to 0? So that means you go ahead and find f prime of x. So now you have f prime of x equals to something. When you plug in x equals to 0, do you think you are going to get a slope? That is what we have to find out. So let's start with the definition, the rules. So differentiability, if f prime of x is equals to limit as x goes to 0, f of x plus h minus the function itself divided by h exists. So that means the derivative exists. F is differentiable at x. The graph of f has a non-vertical tangent line. Non-vertical tangent line because for a straight line, if the straight line is vertical, then the slope doesn't exist, right? So that's why I said non-vertical tangent line. Y equals to mx plus b, slope is equals to m, b is the y-intercept. At x, so the slope, which is m, is either positive, negative, or 0. And in this video, I want to introduce that the f is not differentiable at x in 3 cases. The first case is discontinuity, the second case is vertical tangent, and the third case is sharp corner point. So let's start with the first case. The first case, we have f of x equals to 1 divided by x squared at x equals to 0. So clearly, there is a vertical tangent at x equals to 0. So this one, what I wanted to do is, I want to find f prime of x, and then I want to know what happened when I plug in x equals to 0. So for this problem, you can either use the limit definition or you use the shortcut. I prefer to use the shortcut. So what's the shortcut? I would let's say you never heard of it. So let me give you that right now. So the shortcut is, so let's say you are taking the derivative. dx, you are taking the derivative with respect to x. You have x raised to the nth power. This is easy. All you have to do is you take the nth power down, you take the n down, and then the power becomes n minus 1. Okay, so back to this problem, we have f of x equals to 1 over x squared, so that is x raised to the negative 2 power. And then for the derivative, we have f prime of x, we bring the negative 2 down, and then x raised to the negative 2 minus 1. This is a very simple and basic move that you have to learn in differential calculus. And then you have f prime of x equals to negative 2 on top, and then we have negative 2 minus 1, which is negative 2x raised to the negative 3 power, right? So we have x to the third power in the denominator. So when x equals to 0, then we have, when x is equals to 0, we have f prime of 0 equals to negative 2 divided by 0, which is undefined, right? So undefined. What happened? That means when x is equals to 0, so that means f is not differentiable when x is equals to 0. It's not differentiable. So the slope cannot be measured when x is equals to 0. So how about vertical tangent? So for vertical tangent, you have, I try f of x equals to x raised to the 1/3 and the 1/4. The difference is if what you have to notice is when x is equals to 0, this is kind of flat. When x is equals to 0, flat and vertical. I should say when x is equals to 0. The curve is kind of flat and vertical. I should not use the word flat. I would just say when x is equals to 0, the curve is kind of vertical. But can you just use your eyes to look at it? I would say the answer is no. It is hard to decide when you just look at it. You have to do the math. Okay. So let's follow the color code. I will do both for you, and then I will use the simple power rule. You can use the limit definition if you want to. That will be a lot of work if you do that. So for f of x equals to x to the 1/3, or you can try 1/3, 1/4, 1/5, 1/6, 1/7, 1/8. For the denominator, when the denominator is odd, like 1/3, 1/5, 1/6, you will just get a curve that looks like that. When the denominator is even, 1/4, 1/6, 1/8, 1/10, 1/12, it will just look like this. The graph will just look like that. And then what about f prime? So for f prime, I will bring the 1/3 down and then take the 1/3 minus 1. What is 1/3 minus 1? 1/3 minus 1 is negative 2/3. 1/3 minus 1, just write this out for you. So that is 1/3 x raised to the negative 2/3. So what is this? This is 1 divided by, we have a 3. The denominator is a cube root, and then you have a x squared. So when x is equals to 0, so f prime of 0, you have 1 divided by 3 times 0, which is undefined. Right? So that means the function is not differentiable when x is equals to 0. And then how about the 1/4? So we have f of x equals to x to the 1/4, and then f prime of x. So we bring the 1/4 down, and then x to the 1/4 minus 1. We have 1/4 x raised to the 1 minus 4 is 3, right? So this is a negative 3 over 4. Then we have 1 divided by 4 times the denominator is a 4th root, and then x to the 3rd power. And then clearly when x is equals to 0, you have 1 divided by 4 times 0. That is undefined. So that means for both functions, the 1/3 and the 1/4, f is not differentiable at x equals to 0 for both the 1/3 and the 1/4. And the last case is sharp corner point. So for sharp corner point, you have f of x equals to the absolute value of x at x equals to 0, and then we have a V shape. So when x is less than 0, we have a y equals to negative x right over here. When x is greater than 0, we have y equals to positive x, so slope negative 1 and slope positive 1. My question is the function differentiable at this point in this sharp corner? The answer is no. For this one, I prefer to use the limit definition of derivative. Okay, for that one, I'm going to copy this, and then I will just do it down there because we are running out of space. So I will just copy it and then paste that over here. So first of all, I will rewrite the function as f of x equals to a negative x and a positive x. So this is when x is less than 0. This is when x is greater than or equal to 0. X less than 0 means we have x approaches to 0 from the left. On the other side, we have x approaches to 0 from the right. Okay, so how about f prime of x? So we have f prime of x. We set up the limit as x goes to 0. We are looking for x equals to 0, right? We have x equals to 0. Then this is 0 plus h minus f of 0 divided by h. And then what do we have? This one, let's just use the absolute value of x. I will break down the left and right in the next line. So 0 plus x, so that will be absolute value 0 plus h minus absolute value 0 divided by h. So it turns out we have absolute value of h divided by h. So now I will split up the function. So how about x goes to 0 from the left side? On the left side, we have the function equals to negative x, right? So that means for the h, we will be using negative h divided by h, which is equals to negative 1. Okay, and then x goes to from 0 from the right, then we have f of x equals to positive x. That means we are taking a positive h divided by h that is equals to 1. So that's how we break down the absolute value. Okay, left side we have negative 1, right side we have positive 1. So what is your conclusion? So that tells me they are not equal. So that means the limit as h goes to 0, this does not exist, does not exist. Okay, does not exist. And then what do we say? We say that overall, the conclusion is f of x equals to absolute value of x is not differentiable at x equals to 0. Okay, right? At x equals to 0. So that's it for this video. If you like it, you think this is helpful, give me a like, share, and subscribe, and I will catch you all in the next one. Signing out.